Hello, everyone. Topic of today's lecture is complex numbers. So remember last class I was telling you that I'm going to teach it next time. So let's consider equation, quadratic equation. Give me a second. Choose a pen. Okay, like this. X squared plus 1 equals 0. How do we solve this equation? Well, we isolate x squared, right? Then we try to extract the square root. But what we know is that we cannot extract the square root of -1. It's a negative number. So guys, for some problems, we'll need to extract the square root of -1. So to resolve this problem, we are going to introduce a new number. We have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are going to introduce one more extra number, which is going to be kind of different quality. Like if all numbers are apples, this number is going to turn all other numbers into oranges. So my new number will be number I. Number I is going to be defined next way. I is a number which you square and get -1. So I is basically solution of this equation. And that's exactly different from all other numbers. Well, if we combine normal numbers we had before, real numbers, and numbers which we multiplied by this I, we are going to get a complex numbers. Complex numbers are like a mixture of oranges and apples. So we have apples, which are just real numbers, and we are going to have oranges, which are real numbers multiplied by I. So I'm going to label that real number A is going to be called a real part of a complex number. And B, a real number which sits in front of I, is going to be a complex part, imaginary part. And Z is a complex number. I think I'm missing one. A complex number. So I'm going to write down that A and B are real, and I squared equals to -1. That's the definition of a complex number. Okay, so, well, I don't believe that you never seen complex numbers. I think you've seen. So again, complex numbers have two different parts. Part A, which is just like our real numbers, and part B, which is normal real numbers multiplied by this extra new number I, which you square and get -1. Complex numbers are going to have a special arithmetic. Sorry. Arithmetic. Complex numbers arithmetic. Well, first, how to add complex numbers. Let's consider two complex numbers. Z1 equals 2 plus 3i, and Z2 equals 5 minus I. Well, both have two parts. Real part, imaginary part. Here, imaginary part is 3, and the imaginary part here is -1. So how do we add these two numbers? Z1 plus Z2. I'm going to label it addition. Well, first you copy them. Z1 plus Z2. Then, guys, we are going to add separately real parts. It's 2 plus 5. And we are going to take I outside of parentheses and add imaginary part. Well, here supposed to be plus -I. I'm going to write down just minus I instead of plus -I. Then we simplify it. We're going to have 7 here for real part, and 3 minus 1 is 2I. Okay, so that's how we add them. How do we subtract them? Z1 minus Z2. Again, we copy them first. Z1 minus, and after minus in parentheses 5 minus I. Here, guys, we are going to first open the second parenthesis, or like the parenthesis, which is actually only one, right? -5 minus is going to give me plus I. Now, it looks exactly like addition. We are just going to add real parts. 2 minus 5 is -3, right? And 3I, it's like 3 oranges plus 1 orange is going to give me 4 oranges. That's addition. A little bit more complicated is going to be multiplication. Z1 multiplied by Z2. Well, how do we multiply them? First, we copy them again. 2 plus 3i, 5 minus I, and then we just open parentheses, like doing FOIL or, distributing. So multiply 2 by 5, 2 by I, and 3i by 5, and 3i by negative I. So 2 by 5 is 10, right? 2 by negative I is minus 2i, 2 and minus I, right? 3i by 5, it's 15i. Again, 3i by negative I is minus 3i squared, right? We have one I and multiplied by another I is going to be I squared and 3. Now, guys, we are going to use the property that I squared is equal to negative 1. So we're going to copy everything. 10 minus 2i plus 15i. Minus and minus are going to give us plus, and we are going to have next expression. Now we can simplify it by first adding real part. 10 plus 3 is 13, and then dealing with imaginary part. Well, I'm going to do a little bit more steps with imaginary part. 15 minus 2, but I'm going to get 13i, sorry, just 13, plus 13i. Looks a little bit strange to me. Maybe I'm missing something. No, I think I'm correct. Yeah, I think everything looks fine to me. 59 to 39. Okay, now the hardest is division, guys. Before we do division, we have to define a conjugate. Well, you remember that we already talked about conjugates. If you do have a complex number a plus bi, the conjugate of this number z with bar is going to be a minus bi. So same number, just minus in front of imaginary part. What is interesting about conjugates, if you multiply them, if you just multiply the number and conjugate, you are going to have a plus bi multiplied by a minus bi. Remember the formula, a minus b, a plus b equals a square minus b square. Let's use this formula, special multiplication formula. So it's a square minus bi squared. So a squared, b squared is just b squared, and I squared is -1. And we are going to have minus and minus. We're going to give us plus, and that's a squared plus b squared. So actually, the product of two conjugates is always going to be a squared plus b squared, real part squared, and plus imaginary part squared. Now, let's talk about division. I'm going to divide number z. Well, I don't know. Let's divide number z. I'm thinking maybe z1 by a number 2 plus I. I'll take my z1. Where is my z1? z1 is 2 plus 3i. Let's do 2 plus 3i and divide over 2 plus I. Just division any arbitrary complex numbers. Well, guys, the rule here is going to be multiply by conjugate of denominator in numerator and denominator. Remember that when we multiply conjugates in denominator, we are going to have just a real part squared plus imaginary part squared. So real part squared is 2 by 2 squared is 4, right? Imaginary part here is 1, so it's 4 plus 1. For numerator, we just do a standard multiplication of two complex numbers. So we have 2 by 2 is 4, right? 2 by -1 is -2i. 3 by 2 is 6i. And 3i by -i is -3i squared. We're going to simplify a little bit numerator. And that's 4. -2i plus 6i is plus 4i. And this one is -1, right? I squared. So we have -1 minus 3 is plus 3. And divided over 4 plus 1, which is 5. 4 and 3 is going to give me 7 plus 4i and divide it over 5. Now, guys, I'm going to do one operation which I was teaching you about like a week ago. I'm going to divide by 5 each of these two terms in numerator. Why I can do this? Remember, this is operation inverse of bringing to common denominator. So it's 7 over 5 plus 4 over 5i. And what I see, guys, over here, I had a fraction. Well, this one or this one, right? Over here, this fraction is equal to just a complex number. So I did the division. Well, I think with division, guys, we will need to maybe do more examples. So if you just consider a complex number and divide it by a normal number, by a real number, for example, you consider z equals 2 plus 4i, and you want to divide this z over 2. Well, 2 plus 4i divided over 2 is going to be just 2 over 2 plus 4i over 2, which is going to give you 1 plus 2i. Well, that's what we are doing in the last part. So if you divide by just normal number, it's going to be this, by real number. Now, if we divide a complex number by just imaginary number, by I, for example, or by 2i, for example, we are going to have 2 plus 4i divided over 2i, and the conjugate of this, if your number is 2i, and conjugate of 2i is negative 2i, because we are just changing the sign in front of the complex part. So 2i is actually 0 plus 2i, and this is 0 minus 2i. Sometimes it's confusing. Minus 2i minus 2i. So for denominator, my 2 and 2 is going to give me 4, minus is going to be minus, and I are going to give me minus 1, right? For numerator, we multiply 2 by 2 is 4, minus is coming with I, right? And then minus 2 by 4 is 8, and I square. And we are going to have minus 4i here. This one is equal to negative 1, minus is plus 8. And in denominator, we have minus and minus just 4. Now I'm going to divide by 4 both sides, and I'm going to get minus I, right? It's supposed to be 4 by 4, 1i plus 2. Well, normally, guys, we put real part first and then imaginary part. That's going to be final result. There are special examples of division. So generally, we divide by the whole complex number, but sometimes we divide just by real number or just by imaginary number. Now, guys, what I want you to do one division on your own, okay? So, for example, the self problem to divide 2 plus 5i over negative 3 plus 2i. Okay, I'm going to give you 5 seconds. Turn off your video, try it by yourself, and then turn it on again and see how I solve it. Okay, and I'm going to count to 5. Okay, 1, 2, 3, 4, 5. Okay. So I'm going to start solving it. 2 plus 5i, and the conjugate of my number and denominator is minus 3 minus 2i. We just change the sign in front of complex part, of imaginary part, sorry. Now we just do multiplication in numerator. And guys, if you forgot the formula here, you just can do multiplication too and simplify it after. I remember the formula. I remember that square of this negative 3 plus square of this negative 2 or positive 2 does not matter actually, because it's going to give you a positive number anyway. Okay, and in numerator, we multiply 3 by 2, that's 6 was minus, and then 3 by 5, it's minus 15i, and then minus 2 by 2, minus 4i, minus 2 by 5, minus 10i square, right? I and I square, 2 and 5, 10 and minus. Let's simplify our expression a little bit. So we have minus 6 minus 15i minus 4i, and here is minus 1, so it's plus 10, just minus and minus. This one is equal to negative 1. And in denominator, we have 9 plus 4, right? 3 squared is 9, and this is 4. Well, I'm going to now add a real part. 10 minus 6 is 4, right? And then minus 15 and minus 4 is going to give me minus 19i. Again, I is like minus 15 oranges plus minus 4 oranges, minus 19 oranges, right? Divided over 9 plus 4 is 13. The last step is to divide each of these two top terms and represent it in a complex number shape. Usually, guys, the result of the division are not going to look very nice, but still we did the division possible to do. Now we are going to work with problems which are bringing us to complex numbers. Well, so why do we need these complex numbers? Well, generally speaking, we need them to solve equations when they don't have any real solutions, quadratic equations. How are we going to? Let's just see how we solve quadratic equations. I'm going to write down to solve. Not only, this is not only one need of complex numbers, but in our class for right now, we need complex numbers to solve quadratic equations. Equations with d discriminant less than 0. Let's consider equation x squared plus 4x plus 5 equals to 0. We start to solve it x1, 2 using the formula. So minus 4 plus minus square root of 16 minus 4 by 5 by 1 is 20. That's 5, 1, and 4 from the formula, and divided by 2 by 1, right? We see that we have plus minus a square root, 16 minus 20 minus 4. So actually, guys, we need to extract the square root of negative 4. How we do this? The square root of negative 4. Well, guys, we are going to set by definition. I'm going to set up a question here. Square root of negative r equals I square root of r, and this is going to be a principal root. Principal root means that we use it when we need to kind of find one value for the root. But if you do have the equation, we are usually going to have two roots. For equations, the square root of negative r is supposed to be equal plus minus, right? Plus minus, and that's going to be I and square root of r. Well, how do we explain it? Imagine that you represent minus r as minus 1 by r. And then you extract the square root of minus 1. That's a square root of negative 1 and the square root of r. That's not a very good explanation, actually, because we do not define actually I as a square root of negative I. We are defining it as I squared equals to negative 1. But guys, if you wish, you can square this and have like square of I equals to negative 1. Doesn't matter. For our case, we'll need to know that the square root of negative 4 is going to be equal plus minus I and the square root of 4. And in our case, it's going to be plus minus 2i, which means that my solution is going to look like minus 4 plus minus 2i divided, over 2. And I'm going to divide over 2 first, both terms. So it's minus 2, 4 over 2, right? It was minus, plus minus 2 over 2 is 1. So here, guys, we got two solutions. Solution is minus 2 plus I. And another solution is minus 2 minus I. write down x belongs. Okay. These two solutions are conjugates. Conjugates means that they have one plus and one minus in front of the imaginary part. Okay. Now, guys, I want you to try one problem on your own. So self problem, x squared plus 1 over 2x plus 1 equals 0. Have like 5 seconds. Turn it off. Try on your own for a minute, 2 minutes, maybe 10 minutes, and then watch how I solve it. Okay? And I'm going to count to 1, 2, 3, and provide you with a solution. Okay, solution. Oh, guys, I think I don't want to deal with fractions. So I'm going to multiply whole equation by 2. So I'm going to multiply by 2 everything here. I'm going to have 2x squared. 2 by 1 over 2 is x, and 1 by 2 is 2, and 0 by 2 is 0. Well, again, it's not necessary. You can use the formula with fraction too. I just don't like to deal with formulas with fractions. Now I'm just going to find x1, 2. It's minus, and the coefficient here is 1, actually, when we have no coefficient, right? Plus minus, square root, and again, 1 square is 1, minus 4 by 2 and by 2, right? And divided over 2a. 2 by 2, a is 2. Well, let's see, minus 1 plus minus a square root. So 2 by 2 is 4 by 4 is 16, and 1 minus 16 is a square root of minus 15 over 4. Remember about the rule about square roots of negative numbers. Minus 1 plus minus I square root of 15. 15 is not a perfect square. We're going to keep it as a square root of 15. We're going to divide by 4 real part and imaginary part. It's not going to look very nice, but solution is a solution. Nice or not nice, we can always extract this square root using the calculator. That's our final answer. So I'm going to write down solution. Or 2 solutions actually, right? X belongs to minus 1 over 4 plus square root of 15 over 4i, and minus 1 over 4 minus square root of 15 over 4i. Solutions are always going to be conjugates if you are dealing with coefficients of your equation which are real numbers. So if this is a real number, this is a real number, and this is a real number, and your solutions are always going to be conjugates. Okay? Well, that's all for this section. Please do your homework and practice a little bit with complex numbers. I did not consider any examples of addition or multiplication, but I think you can try them by yourself. Addition and multiplication is kind of easy, right? The only hard one is division. Okay, that's all, and I'll see you in my next lecture.